Hello everybody, welcome to the homework helper for section 3.5. Let's go ahead and get ready. We're going to start by just solving for x. Okay, the first three are going to be just pretty basic two-step equations, right? If we're trying to solve for x here, we add 8 to both sides, we have a third of x equals 8. To undo the 1/3, we multiply by 3, x equals 8, 16, 24. We're done. Okay. Now for 4, 5, and 6, we're given equations as quadratics. So here we have to look at what number can we get for x here that makes this true. Well, that's challenging, but we can do this. We can add 16 to both sides. X squared equals 16. We can square root both sides. So x is going to equal plus or minus 4, because both positive 4 squares to 16 and negative 4 squares to 16. Let me scoot this up. But then we're going to get into a little bit more of a challenging situation with number 5 and 6 here. Now, numbers 5 and 6 have a b term in their quadratics. So now that we have a b term, how do we figure this out? Well, we have to factor it. Okay, we have to find these factors. So x and x. And the way I like to find factors is I like to use the x method. Okay, what two numbers multiply to multiply to 3 but add to 4, right? So we're trying to see what numbers there's like two numbers here that will add to 4 but multiply to 3. Go ahead and think about what those numbers could be for a second. And it's going to be 3 and 1, right? 3 times 1 is 3, but 3 plus 1 is 4. So this is going to be x plus 3, x plus 1. So this and this are the same thing. So what does that mean? Well, let's look at our equation. If we have x plus 3, x plus 1 equals 0, look at what's going on here. These are two numbers being multiplied together. And if two numbers are being multiplied together, and it ends up equaling 0, that means either this one, x plus 3 equals 0, or this one, x plus 1 equals 0. Because if either of those equaled 0, then the whole thing would equal 0. So this would happen when x equals negative 3, right? Negative 3 plus 3 is 0. And it would happen when x equals negative 1. Negative 1 plus 1 is 0. So we're going to end up with two answers. As a general rule, whatever power your x is to is how many answers you're going to have, right? If x is to the first power, we're going to get one answer for x. If x is to the second power, we're going to get two answers for x. And if x is to the 3, we get 3 answers, and so on and so forth. But for the sake of this one, all we have to do is see that, let's go to number 9 here, okay? If this equals 0, then the whole thing equals 0. So 3x minus 18 equals 0. Or if this equals 0, then the whole thing equals 0. So 3x equals 18, x equals 5. If x is 5, then everything will equal 0. And then if I add 10, 5x equals 10, x equals 2. So at 2 and 5, this will equal 0. Okay, so, whoops, I got my little picture blocked that off a little bit. So that's what's going to cause the entire equation to be 0. We're looking for those two answers. One factor equals 0, the other factor equals 0. And so we can set all of those up the same way. Set this equal to 0, set this equal to 0. Set this equal to 0, set this equal to 0, and then for this one, factor it like we did in number 5. All right. Next, dividing polynomials. So what we're going to be doing here is figuring out what we're going to do this like old school long division way. We're going to figure out what we have to multiply things by to get this long division to work. So what do I have to, and we're just going to start with our first term. Okay, let's just start with our first term. Let's just start with the x. Let's ignore the plus 1 for the time being. What do I have to multiply x by so that it's x cubed? Okay, x times some number is going to be x cubed. Well, this would have to be x squared. So I'm going to write that right here. I have to multiply it by x squared. So what happens when I multiply x plus 1 by x squared? Well, I'd get x cubed, x squared times x, but then x squared times 1. X squared times 1 would be plus x squared. So now I'm going to add these together. Negative 3x squared plus x squared is going to be negative 2x squared. Okay, that's going to be my remainder there. All right, so now I'm going to bring it down just like I did in long division. So plus 6x. Now I'm going to be doing the same thing. What do I have to multiply x by to get negative 2x squared? Well, I need another x, so times x, and I need the 1 to become negative 2, so negative 2. So I'm going to multiply that by negative 2x. That'll give me negative 2x squared, and then negative 2x times 1 is negative 2x. Okay. Going to combine those. Subtract, subtract. This becomes 8x. Bring down the 11. Okay. Now I'm going to do the last little part here, bring down the 11. What do I have to multiply x by to get 8x? Well, I have to multiply it by 8. That'll give me 8x. 8 times 1 is 8, plus 8. When I subtract, those eliminate. A negative 11 minus 8 is going to be a negative 19. So this is my remainder, and the way that I write the way I'm going to write my remainder is I'm going to say minus 19 divided by whatever we're dividing by, x plus 1. So this would be my final statement. This would be x squared minus 2x plus 8 minus 19 divided by x plus 1. Oops, 19 looks ugly, but that would be my final beautiful statement there. And then it says it wants us to write the multiplication statement. So what we would say is this, that thing we originally divided by would be the same as our new answer, x squared minus 2x plus 8 minus 19x plus 1s times what we originally divided by, x plus 1. Boom, done. Okay. I'll do another one of these. So I'll do number 11 here. So what do I have to multiply x by to get x cubed? I'd have to multiply by x squared. If I multiplied it by x squared, this would be x cubed minus 5x squared. I'm going to subtract 0. Negative 9 minus a negative 5 is negative 9 plus 5, which would be negative 4x squareds. All right, bring down the 23. What do I have to multiply x by to get negative 4x squareds? That would be negative 4x's. Negative 4x squared plus 20x. When I subtract, I'll get 3x. Bring down my 15. What do I have to multiply x by to get 3x? 3. That gives me 3x. 3 times negative 5 is negative 15. And I actually cancel out here. So this would be my answer. And then to write that as a multiplication statement, I would take my answer, x squared minus 4x plus 3. And I would multiply it by what I divided by, and that would be the same thing as that third power polynomial that we just had. Cool. All right, let's go on to the next one. We're going to be graphing functions and identifying their features. Okay. Graphing functions and identifying their features. So I'm going to start with number 16. We're doing x squared minus 9. This is going to be a parabola where we are doing a vertical shift down 9. So draw my axes. What are the features? So x squared minus 9. So I'll start it, remember our basic form, a x minus h plus k. And then whatever power we're doing. Here it's squared, so we know that we're doing a parabola. So we're going to use, whoops, it helps if it's actually on the screen. So we're going to be doing a parabolic graph. My HK is going to be my central location where I start everything in a parabola. That's going to be a vertex. So my HK is 0 minus 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm going to start right here. Okay, and then I'm just going to follow the basic pattern of a parabola, up 1, over 1, It's 2. 2 squared is 4. 1, 2, 3, 4. 3 is 9. Puts me here. And then I'm going to be off the graph by then. And then it mirrors, because parabolas mirror, because squaring causes negative numbers to become positive numbers. And so my shape kind of looks like this. Okay. Awesome. So now it asks me my domain. So what are the possible values in my domain? Now domain is going to be your x values. So what are the possible values? Well, if my graph were big enough, it would just keep going on and on and on, wider and wider forever. So my domain, the smallest number is a negative infinite. The largest number is infinity. Okay. Now, what about my range? What are my possible y values? Well, it appears to never go below -9. So -9 is the lowest value I can do. But it's going to keep going up forever. So I'm going to say it goes on to infinity. And remember, brackets are, or parentheses, we use those for infinity or for if it approaches a number but never touches it. Brackets are it touches it. So it actually does touch -9. So I use the bracket to say it touches -9. All right. Where is it increasing? And when we're talking about increasing, we're talking about increasing on our y. Well, we see at 0 all the way up, it starts to go up. So it increases from 0 infinitely. But where is it decreasing? Well, as it comes in from -infinity, it's coming down, but then it stops decreasing at 0. So I'd say it's decreasing from -infinity to 0. What are my y-intercepts? Where does it cross the y-axis? Crosses the y-axis at -9. My x-intercepts appears to cross at -3, and then again at 3. Okay. And so that's how we're going to do all of those. For 17, we're given it in a recursive form. So we know that our f of 1 is 4, right? So we know, I'm going to draw this out. Our f of 1, our first term is 4, so 1, 1, 2, 3, 4. And then I know that each consecutive term I'm adding 3. So I start at 1, 4, and then I add 3, 1, 2, 3, at 2, and then I add another 3, 1, 2, 3, and then I add another 3, and then I just keep doing that forever. So what's our domain? Well, our domain are all possible x's, but look at our x's here. It's not like our parabola where we had to draw it all out. We're only given one term at a time. So I know 1, 2, 3, 4. So our domain is 1, 2, 3, 4, etc., on and on. Okay. So it's just going to be those whole numbers from 1 on up. Okay. So just those whole numbers, positive. That's it. What's our range? What are our possible range values? Well, our range starts at, what is this, 4, 7, 10, 13? 4, 7, 10, 13, ... and on. So it's multiples of 3 starting at 4, right? That's going to be our range for this one. Where is it increasing? Well, it's increasing throughout the entire thing. It's always going to be increasing. So from 1 to infinity, it's increasing. Where is it decreasing? Well, it's not decreasing. It's going to go on forever. So NA, not applicable. Y-intercept? Well, we started at 1, right? We didn't start at 0, right? It told us to start at 1. So there is no y-intercept. And then x-intercept? Well, it started all the way up at 4 as increasing. So there's never going to be an x-intercept. So for these, you just kind of have to look at them, process that, and go from there. I strongly, strongly recommend that as you're doing this, plug these equations into Desmos to get an idea of how they behave as well. For example, I was looking at this one here, number 19, right? Number 19, it's like log base 2 of x. And I know we've graphed that together. It should be in your notes. But sometimes that might be a bit of a challenge to remember all of that. So here, I pulled it up just like so. Whoops. So just pop into Desmos and plug it into this graphing calculator to see how it behaves. See here, 2x minus 1, I believe it was. So here we see how it behaves, right? Look at that. So we're able to figure out what our domain is. Like, look at your paper right now. The first thing it asks is your domain. So what are the possible values for x? Well, it appears to be from 0 to infinite, but it doesn't ever touch 0. So when you put 0, you do a parentheses with it. What's our range? Well, it seems to go on to negative infinity to a positive infinity. It's increasing the entire time. It's never decreasing. And the intercepts, the y-intercept, it will never touch the y-axis. There is no y-intercept. But the x-intercept we can see is right here at 2. So use your graphing calculator to help you be more familiar with this. Use the tools available to you. Use Desmos to help figure out what these shapes can be if you're not familiar enough with them to come at it completely off the top of your head. All right. Persevere. Keep doing this, and you'll get better at it. And we'll come back tomorrow, and we'll do some more there. See you in class.